Today we're going to learn about logarithmic functions, which is found in section 4.6 of your BJU Press PreCalculus textbook. So a logarithmic function is just the inverse of an exponential. So we're going to take a look how to convert in between exponential and logarithmics. And then once we've done that, we will talk about how to evaluate logarithms using your calculator. And then we'll take a look at the graphs of logarithmic functions and their domains and ranges and how to translate them and all kinds of things to do with the graphs. So let's go ahead and take a look at what we are going to see as the definition for a logarithmic function. So the definition of a logarithmic function is the inverse of the exponential function. So remember, an exponential function is where the variable is in the exponent. So that was the definition of an exponential function. And so the definition of the logarithmic function is the inverse of that. So here is a picture of an exponential function, 2 to the x power. So remember, the inverse graph is going to be across the line y equals x. Okay, so we're going to reflect that. And when we reflect that, we get the graph of the inverse of our exponential function to the x, which is the logarithmic. And so this is what our graphs of logarithmic functions look like. So our logarithmic function is going to be defined as f of x equals log, and then we say base a for this part. So log base a of x. And so your a, your base, has to be greater than 0, and it can't be equal to 1, and then x has to be greater than 0. So that actually kind of gives you a hint on your domain. Your domain is all real numbers except for x is greater than 0. And we talked about how it's the inverse of the exponential function, which was f of x equals a to the x. And remember, the a in the exponential also had to be greater than 0 and could not equal to 1. So when we're converting, there is a rule that says log base a of x is equivalent to a to the y equals x. So I think of this as a log loop, or what I call a log loop. You start with a, and then you take it to the y, and it's equal to the x. Or if you can go backwards, you're going to do log a of x is equal to y. So as you can see, it kind of makes a loop. So a is the base of the logarithmic, and it's also the base for your exponential. So the logarithmic expression can be written in either of the two forms, the log form or the exponential form. So to change it, you just take your base of your log and make it the base of your exponent. And so let's take a look at an example. We have log base 4 of 64 equals y, and we want to write it in exponential form. So if I were to do my loop, I would have 4 to the y equals 64. So this one, write 3 to the negative 5th equals 1 over 243 in logarithmic form. So remember, our base is going to be the same base as your exponential. So you have log base 3 of 1 over 243 equals negative 5. So by converting between log and exponential, you have a proof that log base a of 1 equals 0. Because if you were to rewrite log base a of 1 equals 0, that would be a to the 0 power equals 1, which is true. So that proves that log base a of 1 equals 0. Another thing that you should know is that if you're trying to do logarithms in your calculator is going to have them as common logarithms, which are in base 10. So we were dealing with different bases earlier. We had a base A for the definition, and we had different bases that we were working with. But your calculator only does common logarithms, which is in base 10. And usually if you have a log and it just says log of a number and there's no base, it's a common log, which means it's in base 10. They usually don't write the 10 when they're writing it out. The second special type of a logarithm is called a natural logarithm, and that's base is e, but instead of saying log base e of a number, they're going to say ln of a number. That's a special notation for a natural logarithm is ln instead of saying log base e. E is an irrational number that's approximately 2.71828, and then it repeats over and over and over. We call that Eulers number. Just so you know, this is the definition of Eulers number, where it came from. It's basically the limit as you take 1 and you add like a smaller and smaller fraction. So as n approaches infinity. So you get 1 plus 1 plus 1/2 plus 1/6 plus 1 over 24. Like it just keeps getting smaller and smaller and smaller. And that's how they got the 2.2 ... That's the number E, Euler's number. All right, go ahead and try some problems on your own.